In this section, we've been talking about intersections, and we'll also talk about unions. But here on intersections, let's talk about some kind of nitty-gritty details, and I don't expect you to necessarily memorize all these, but you should be able to figure them out. So if I asked you, you should be able to tell me what they should be. So this one is A intersect B. So let's draw a picture here. Here's A, here's B. If we look at the intersection, it would be this part in the middle. Okay, now it's saying it should be equal to, it would be the same thing, so we still have A and B, as if we did B intersect A. And in this case, it doesn't matter which one you say comes first, the intersection is still the part in the middle. And if you happen to have a situation where you have A and B and they don't even overlap, well, the intersection would then be nothing. And again, it doesn't matter which that you say comes first. Okay, our next one is A intersect S equals A. Now remember, S is your entire sample set. So here's my S, here's an A inside of it. If we do A intersect S, well, where do the two overlap? Where do they meet? They overlap here, or they overlap everywhere that A is. So we would get back to A. In our next one, we have A intersect A complement. Well, to find A complement, or first to say, okay, here's A, then A complement is everything outside of A. So here's A complement. Where do they intersect? Where do they overlap? They never overlap, so you get back to the empty set. Let's say A intersect A. Well, here's A. I can't draw another A. This is A. So here's A. Here's my other A on top of it. Where do they overlap? Well, everywhere inside of A. Let's see an A intersect the empty set. Well, they never overlap because there's nothing in the empty set, so you're just back at the empty set. Okay. And our last one, notice we have three different events, A, B, and C, A, B, and C. And notice they're just changing the parentheses, so they're saying, let's group B and C together first and see where they overlap, or let's group A and B first and see where they overlap. And it doesn't matter. You can do them in any order, you can group them together in any way. You're not going to get different answers. Now at this point, we've skipped ahead, so now we've talked about unions. And remember, a union is an OR. Okay, so it's wherever we have A or B or both. So let's remind ourselves, A or B or both. If you're talking about A union B. So A union B means A or B or both. Okay. So if we have A union B equals B union A, that just means it doesn't matter which order you say it in, you get the same answer. Okay. And A union the empty set, well, so it's A or the empty set or both. Well, the empty set has nothing in it, so A or nothing or both. There's nothing in the both part where they overlap, so you're just back at A. And A or both would again just give you A. Let's go ahead though and look at A and A complement. What happens if you put the two of them together? So we shade everything in A. We also shade everything in A complement, or both. There's nowhere that they overlap, so there's no both. But notice we've gotten everything in the original sample space of S. And if you do A union S, which is the entire sample space, you have everything in A, or the entire sample space, which just gives you your entire sample space. And again, finally in the bottom, again, it doesn't matter if you change the order or you change which ones you group together first, you'll get the same results.